Okay, so I'm going to share my screen now. Oops. This is the one I want to share. I'll hit share. Alright, my young friend. How's that? Can you see my screen?
I see it.
Okay. How about me? Am I on there any place, like down in the corner or anything?
Yeah.
Am I? Okay. Alright, good. So, Stuart, this is going to be just a brief lecture, tonight about dimensioning, because we're going to start doing dimensioning with our drawings on Friday of next week. As a matter of fact, we have due a couple of drawings. You're supposed to put them onto title blocks and stuff. The first two, what were they called? I'm going to scroll down here. It was this one from day 6, the bracket and shaft guide. So these two were due on February 16th, so you should have them done. Anyways, and I think you do, if I remember correctly. So we're going to use those two drawings next week in class to actually do some dimensioning with them. So that you knew that or know that, okay? So I've just scrolled down here to week number 10 on our class, and I'm going to read this paragraph, really brief, 3 sentences here. It says, tonight we're going to look at some of the rules, okay, and that's in quotation marks, of dimensioning. The reason I say that is because sometimes it's okay to break these rules. Rules is a really restrictive word. A better phrase might be best practices. So we're going to see Chapter 5, Part 1, the basics of dimensioning PowerPoint. That's this PowerPoint right down here. As a matter of fact, we probably won't go through the entire thing, but at least we're going to cover some of it. Let's see. All right, this is the one. So this is Chapter 5 in our book, okay? It's a new chapter. I've asked you to read it. I don't know if you've gone through and done the course reading for that or not. If you have, great. If you haven't, well, try to get to it. So, last chapter, Chapter 4, you used dimensions and notes that were taken from a designer's sketch. This is what a designer might have a drawing look like, or an engineer. This is how they're going to, perhaps, on the back of a napkin, draw something. They don't always do that, but sometimes they do, and you get a sketch that looks similar to this. Now, in this chapter, we're going to learn how to add dimensions to these projects, and some of these best practices are what we're going to talk about. So, for each of these first 4, okay, here's the bracket, shaft guide, and I can't remember what the name of these 2 guys are, but these are all here on our screen. You can look at yours and double check it. I'll be looking at your drawings more closely once they're on title blocks. And so just make sure you get those drawn up, and we'll be looking at dimensioning those. So in theory, if the designer's drawing or a sketch has 15 dimensions and a note, all you need to do is add the same 15 dimensions plus the note to the views of the object in order to continue dimensioning the drawing. There'll be times, most of the time when I worked in doing this kind of work, I never received an actual drawing with dimensions on it from the designer like this. It was usually given to me, and then I had to create the dimensioning plan for it. So in practice, it's a little bit more complicated, just like I just was mentioning to you. So you have to make sure as a drafter or as the designer that these 15 dimensions are represented in the drawing to the exact same precision, which is the number of decimal places, as we see on the designer's sketch. It could be that you have a drawing that has something to 1 decimal place. In other words, it's dimensioned with an accuracy of 0.1. 2 decimal places, it would be 0.11. 3 decimal places would be 0.111, or whatever the number is you might want to use there. You'll hear me use this word datum in relation to our drawings, okay? And datum is a theoretically, so again, quotation marks, perfect element. A datum could be an edge, it could be a surface, it could be an axis, so the middle of a circle. It can be any kind of geometric feature where you put a dimension onto something. Features of finished parts that are going to be inspected by measuring the distance between the datums and the features that are described on the drawing. The use of datums is going to be presented a little bit later on in the chapter 5. But here we go. Before you place the dimension, the drafter has to choose the view where the feature will most clearly be described by the dimension. For new drafters, that's sometimes a difficult decision to make. And there are guidelines for spacing and formatting of dimensions. And you have to be familiar with these guidelines so that you know how to control the AutoCAD dimension settings necessary to compete with the guidelines. So there are 2 types of dimensions. All right, this is the kind of a really important point: size dimensions and location dimensions. So in this figure down here, the overall width and height of the part and its features are size dimensions. So the overall length is a size dimension, the height here is a size dimension, and the size of this hole is a size dimension. Location dimensions is going to be things that tell you where the hole is located. So location dimension is this one, 2.89, and then this one over here on the right hand side for 8.4. So size shows you the overall dimensions or the size of things like holes or radiuses, and then location dimensions do position the parts. So dimensioning terminology, we'll use these terms a little bit during class, all right? That's shown in this next figure. And an extension line is the line that comes from the part out. So that's an extension line. And extension lines always have a gap between the extension line and the edge of the part, all right? Here on this circle right here, okay, the dimension, the 0.84, which is going to be a dimension line, okay, it's excuse me, not a dimension line, it's a location dimension. That 0.84 you're going to see crosses the object line and goes all the way over to the center mark that's on this diameter over here. So this is the dimension line. This is the dimension text. This points to an arrowhead. So there's arrowheads at both ends of dimension lines. And then the dimension text is typically centered on the dimension line right there. This guy right here, 2.9, that's a location dimension. And this 6.75 is a size dimension. And the 3.0 is a size dimension also. The angled line that comes from a part, that's going to be called the leader. And the leader is typically between a 30 and 45 degree angle. It doesn't go straight up and down. It doesn't go straight to the left or to the right. It just goes up at an angle like this. It can go to the 30 degrees over here. It can go to 120 degrees like this one is. It can go down to the left or down to the right, but it has to be angled. Okay. Different kinds of dimensions. An angular dimension is this guy right here. It has that little bubble up into the right hand side of it that indicates degrees. We also have on here a diameter symbol. That's the circle with a slash through it. That goes for anything that's 360 degrees. Okay, that is a diameter. So a diameter is always measured on a 365 degree circle. Okay. Radius symbol is the letter R. That indicates that's, I'm sorry, 360 degrees, not 365. A radius symbol is used with a capital R, and that indicates anything that's 359 degrees or less. When you see a dimension, when I see a dimension just like this right here that says 4.33, and what you might notice is that is in parentheses. That means that this is a non-inspection dimension. So it's kind of like a note that says, hey guy who's making this thing, this dimension is 4.33 inches tall. It can be useful sometimes in dimensioning of parts, but what I find is that it's kind of confusing. I don't like to put that type of parentheses in. And if you do this kind of thing, it's called over dimensioning. And I will, when I correct a drawing and I see this type of thing, I will put what's called a double dimension mark on it. So I'll write DD on it, and that stands for double dimension. We have location dimensions here for this circle. Down here we have the diameter symbol, and we have this V. This indicates to me that to a diameter of 2 inches, so the outer circle here is going to be a diameter of 2 inches, that this is a counter sink. In other words, it's a hole that has walls that are at angles like this, times 82 degrees, which means that from the tip of my finger here to the tip of my finger over here, that would be 82 degrees. So later in this chapter, you're going to be required to relate some of the terminology that's shown in Figure 5.2 to the corresponding settings in AutoCAD's Dimension Style Manager dialog box in order to create a dimension style. Now, next, and this gets taken care of a little bit by our dimension features, I guess is the way to put it. This is the recommended size and spacing of them. So when you look at this, what you'll notice is this is the object line. Okay, that's the line that goes around here. Object lines are dark lines and they're usually thicker. We use the layer visible for our object lines. And then we also have on here an object line where this circle is going around and around right here. So our very first line, the distance from the object line to the dimension line, should be somewhere around 0.4 inches. 0.4 is 3/8 of an inch, 0.375. That's the standard, that's the Americanized numbers, I guess is the best way to put it. So the distance from the object line to your first dimension line is going to be 0.380 or 3/8 of an inch. Now from this dimension line here to this dimension line, that distance changes to 1/4 of an inch, 0.25 inches. So the distance from here to here is 1/4 of an inch. Okay. We also have the length of our arrowheads is going to be the same height as our dimension text. And dimension text on a printed drawing is typically going to be 1/4 of an inch. I'll show you, probably we'll start talking about this on Tuesday next week on our title blocks about how to set up what are called dimensioning styles, so that we can use 1-place decimals, 2-place decimals, 3-place decimals. Okay. There are multiples on here that I'm not going to go through right now that are controlled by the dimension settings, and that we'll talk about in another project or another day. So guidelines. Whoops. Oh, look at you. That shortened that up, smalled that up. All right. So here are 5 guidelines that will allow you to determine the best location and placement of dimensions on a drawing. The first thing is put dimensions on the profile of the picture. So if we take a look down here at this first set of 3 drawings, the front, right, and top view, they're going to show us some poorly placed dimensions. On the right hand side here, they're going to give us some properly sized dimensions. Okay, all right. So something to keep in mind, you want to avoid dimensioning to hidden lines. So when I correct drawings and I see dimensions to hidden lines, I'll cross it off and I'll write HL next to it. That indicates that you have dimensioned unintentionally, hopefully, to a hidden line. Okay. You also don't want to dimension to center lines of hidden holes. So for instance, down here in this poorly placed dimensions, that's exactly what they did. They go in this right hand view from this left hand object line to the center line of this hole here that is hidden lines. That's not a good practice. Okay, you don't want to do that. Let's see, whenever possible, you want to group dimensions and place them between the views of the object. So you might notice this set of dimensions right here. Okay, this dimension is right inside of the part. That is not a good thing. So that's placing them on the object, and you don't do that unless it's really, really, really necessary. And it's just a better policy to just not do that. Okay. Let's see. So avoid drawing extension lines and leaders through dimension lines. Let's see. Can I zoom in on this a little bit? Automatic zoom. Oops. Let's try 200%. Okay, so this guy up here, what they're talking about is the this 2-inch dimension. See this dimension right here, and this 3-inch dimension. And then we have, of course, this leader line going through right here. So you'll notice that the 2-inch dimension is shorter than the 3-inch dimension, and it should not be up here. It should be closer to the object line right here. This radius of 0.5, well, this is kind of a long ways away from our circle. It might be better off placed over here in the upper right hand corner, or like they did it over here on the right hand side, they've got the leader line down in here to the right. It's a bit shorter, so the person who's reading the drawing doesn't have to look really super close at the thing to try to figure out where this line is going before they get there. So let's talk about some of the great things that they did over here. We'll talk about the front view first. All right, so this bottom line, and what you'll notice is that they have dimensioned from the bottom line up, and they repeated that by going from the bottom line up to the top part here. The shortest dimension, 1.5, is 3/8 of an inch away from the object line to the dimension line. So that means that this is done nicely. And then we have the 2.5, which has got 1/4 of an inch between this dimension line and the one on the right. And you'll notice that they are the shorter one is inside of the longer one. And this dimension is right in between the sketch views. Okay, they have dimensioned this surface right here on the right hand view. I wouldn't argue about this dimension if it was put over here onto the view on the front and you had 3 dimensions, but this is the first rule that we have up here, that you should place the dimensions on the profile view of the feature. So in general, I place dimensions on the view that describes the feature the best. That's the policy that I try to adhere to. You'll also notice that the dimensions here for this part are basically in between the views. They're not like this one is above the view. They're not on the view. They're not to the left of the view. They are in between the views. Now this is this view up here with this 1-inch and 3-inch dimension. That's fine. That is between the views. So there are instances where I do put dimensions on opposite sides. Not very frequently, or as infrequently as I possibly can, but just be mindful of that. Let's see. Okay. So this next slide here is going to talk about what's called the ASME Y 14.5-2009 dimensioning standards. So, and these standards are published by the American Society of Mechanical Engineers. That's what ASME is. And Y 14.5, I don't know. That changes. This value changes every time they update these. This PowerPoint says that 2009 is their most recent version. I'm not sure if these have been updated since then or not, but this book is kind of like the Bible of dimensioning, okay? What I found out over the years, though, is that big companies like Eastman Kodak in Rochester, IBM, that's Xerox, that's in Rochester. They've created their own dimensioning standards and such. So they just say, hey, here's our standards. We'll follow this rather than using this. But in general, drafters across this country are going to use these ASME standards. In this slide, this is a repeat of the one earlier where we talk about the distance from the object line to the dimension line, and from dimension line to dimension line, and the length of arrowheads and stuff like that. So there's really no point in hitting that one too hard. All right, so dimension, text, height, and style. So when we put text on technical drawings, you need to make it legible, okay? That is the primary concern. The ASME standard governing text, height, and style on engineering drawings is in the ASME book under line conventions and lettering. This standard states that text used for titles and to denote special characters like section view labels should be not less than 1/4 of an inch, and that all other characters should be a maximum height of 0.12. We made our text height 3/16 of an inch, which is 0.1875, and is perfectly fine for doing this. It's greater than 1/4 of an inch. Uppercase letters should be used. Lowercase letters. Okay, excuse me. I'll read that sentence again. Uppercase letters should be used unless lowercase letters are required. I'm going to say that for the most part, I would always use uppercase letters. Okay. I know that in text language and email, if you write in uppercase, that is considered shouting. Well, drafters shout. It's simple as that, okay? And you want to use what's called a non-serif type of dimension text. In other words, they don't have little lines at the end of a number or a letter. It makes it easier to read, okay? Let's see. Alignment of dimension text, length, height, placement of, location dimensions. This is about the orientation of dimension text, okay? So in mechanical drawing, all of our dimensional text is going to be what they call unidirectional. In other words, you read it just like you see it right here. It goes across, not up and down. It's not rotated like you see here on the right hand side. So this is an ASME typical standard for mechanical drawings, that your dimension text is read in this orientation like this. Aligned dimension text, that's what this type of dimensioning is right here. This 0.84, this 0.212, that is aligned dimensioning text, okay? That is used in architecture. So when you're working with David in his class, his architecture class, you're probably going to have to set up your dimensioning aligned. So that will be something that you want to keep track of, and something that you want to actually use when you're doing architectural drawing. But in mechanical, we use the unidirectional. Okay, let's see, how long have I been talking? Oh, almost 30 minutes. Stuart, I'm going to tell you what, I'm going to stop right here, okay? And I'll pick this up on Tuesday in class. We'll do a little bit more with this. What I am going to do, I don't want to call it this. I don't want to call it a quiz. You're going to be, I'm going to excuse you. I'm going to stop sharing my screen first. Hold on a split second. Stop share. I'm going to turn my